A three-stage missile, MX will be 70 feet long, 92 inches in diameter, and weigh about 190,000 pounds. MX is the largest new missile permitted under the SALT II agreement, and its 10 warheads and 7,940-pound payload are the maximum allowed under that treaty. The first stage motor will contain a high-energy solid propellant, already tested in static firings, along with the new steerable single nozzle concept. The second stage will use a new high-energy solid propellant with another new development, an extendable nozzle exit cone. This nozzle extends at altitude, allowing greater expansion of the exhaust gases, thus increasing performance. The third stage motor also will use an extendable nozzle and a new solid propellant of even higher energy than the lower stages. A liquid propellant fourth stage will provide the maneuvering ability and precision to dispense the 10 warheads to individual targets. The guidance system, based on the Advanced Inertial Reference Sphere concept, has been developed and tested. This system, along with the new computer, will provide MX the flexibility necessary for a ground mobile system. The reentry system will house warheads of the same or better quality than the reentry vehicle previously developed for Minuteman III. The first flight test of the MX missile is scheduled for 1983 from Vandenberg Air Force Base, California, with the first 10 missiles operational in mid-1986. The MX basing mode is a multiple protective shelter system. The planned cluster deployment areas are located in the southwestern United States. This photograph of a typical valley has been retouched to simulate the locations of shelters and roads. The following animation of the basing mode is not drawn to scale, and the shelters and roads have been intentionally enlarged to clearly depict the operation of the system. A cluster road will connect 23 horizontal shelters which support a single MX missile. A specially designed transporter will move the missile in its launcher on unpaved roads between shelters. A 2.5-acre area around each shelter, roughly the same size as currently surrounding each Minuteman silo, will be fenced for security reasons. All other areas will continue to be open to the public. The MX system is currently planned for 200 missiles and 4,600 shelters. The MX shelters and support areas will require about 25 square nautical miles of land to be removed from public use. Other activities, such as mining and ranching, will be permitted in the areas between the shelters. Private aircraft will be permitted to fly over them in accordance with FAA flight rules. Each of the valleys that appears usable based on geological considerations will accommodate several clusters. Adjacent complexes will be interconnected by service roads unable to support the weight of the transporter. Thus, a single MX missile will be constantly associated with a cluster of 23 protective shelters. Several factors contribute to the survivability of the system. Each shelter will be about a mile from any other, so that one enemy warhead could not eliminate more than one shelter. The transporter vehicle carrying the missile and launcher would periodically move on unpaved roads from shelter to shelter. At one of the 23 shelters, the missile and its launcher would be installed. A mass simulator with identical weight and other properties would then replace the missile and launcher in the transporter. These simulators would have been installed in each shelter at the time of construction. At each remaining shelter, installation procedures using the mass simulators would be carried out, so that Soviet surveillance systems would not know which shelter actually contains the missile. Additionally, electromagnetic and other emissions would be simulated in each empty shelter and in the transporter. Normally, the MX missile would change shelters within its cluster only after a routine maintenance cycle, perhaps a few times per year. If compromise of missile location is suspected, the system could operate in two additional ways to maintain its survivability. First, all missiles could be relocated to other shelters in several hours. Such a reposturing would ensure that all missile locations remain undetected. Secondly, the transporter with its missile and launcher could be placed in constant motion. Upon tactical warning of attack, the missile and launcher would be deployed into the nearest shelter. Through a combination of concealment and mobility, the security of the MX system can be maintained. As a result, the Soviets must target all 4,600 shelters to destroy a significant number of MX missiles, which in itself should deter such an attack. Should the National Command authorities require MX to retaliate, the shelter door would open, the launcher would emerge, erect, and eject the missile. The first stage would ignite, and MX would be on its way to its assigned targets. Many tests have been conducted in the evaluation of the various basing mode concepts. This 1.4 million pound transporter vehicle is now being used for roadability and maneuverability testing. Several different types of dirt and gravel roads have been constructed for the vehicle to operate on to determine cost and durability. Scale models of horizontal shelters were constructed and subjected to high explosive blasts, simulating nuclear environments to gather design data. Large sheltered doors were constructed and tested in debris studies. This data is being applied to the current design. Missile ejection from a canister has been repeatedly demonstrated in a series of design feasibility tests, and the concept of free flight ignition, or cold launch, has been demonstrated in the Polaris, Poseidon, Trident flight tests. The MX system has been conceived to maximize SALT verification. The design enables Soviet surveillance systems to determine how many missile launchers have been assembled and deployed. First, at the designated assembly area, all missile and launcher components would be received from their manufacturers. Assembly would occur in facilities with openable roofs to expedite observation for SALT verification. Only one missile would be assembled at a time, with the process taking about a week. The assembled missile in its launcher would be transferred to the deployment area using a special transport vehicle on a designated transportation network. Each shelter cluster would be accessible only through a major verification barrier. The special transport vehicle would deposit the missile in its launcher at the cluster maintenance facility. After the special transport vehicle leaves, the barrier would be reinstalled, ensuring that a second missile could not be introduced into that cluster. The missile in its launcher would be loaded into the transporter in the cluster, the only place this unit will exist in operational form. This combined unit would now visit each of the 23 shelters, with the missile and launcher being installed inside one of them and its place in the transporter taken by the simulator. This entire assembly process would be repeated for each shelter cluster and would be reversed should removal of any missile be required. Emplacement of an MX missile and launcher for each set of shelters would complete deployment for that valley. As another verification feature, each shelter would be fitted with ports, which could be removed for inspection. This would allow Soviet surveillance systems to verify the number of deployed missiles. The transporter itself is another aid to SALT verification. Just slightly smaller than this earlier version, at a loaded weight of up to 1.25 million pounds and a length of 180 feet, the transporter will be too heavy and too cumbersome to travel off-road or on other than the specially constructed roads. It would sink into the surface, be trapped by terrain variations, or tip over. Every effort will be made to minimize the environmental impact of the MX. In addition to withdrawing as little public land as possible, the shelters and road networks are being designed to be nearly flush with the ground for maximum landscape blending. It should be remembered that a typical valley with shelters and roads drawn in to actual scale would look like this photo rather than as depicted for clarity in the animation. The required environmental impact studies are underway. 2 have been completed and 2 more are in process, one for selection of a deployment area and the other for a production decision in 1983. There may also be supplemental environmental impact statements. MX will be as energy self-sufficient as possible. Each shelter may require approximately 20 kilowatts of power. To generate the power required, the use of solar or other renewable energy systems, such as geothermal plants and windmills, will be investigated to reduce the need for commercial power. The overall cost of the MX system during its 10-year acquisition period is about $33 billion in 1980 constant dollars. Its operating costs are $440 million per year in 1980 dollars. As a comparison, our Minuteman system cost $40 billion in comparable dollars, and its operation averages about $340 million in 1980 dollars. Our B-52 program cost $54 billion in 1980 dollars, and Trident will cost $39 billion. Since both are manned systems and more labor-intensive, the operating cost of these systems runs about 3 times the cost of MX. MX has been sized within the constraints of SALT II and to a level necessary to maintain the deterrent posture of our strategic triad. With SLBM forces at near parity and the U.S. bomber forces with an advantage in cruise missiles, it is important that the MX role be one of assuring a balance with the Soviet ICBM forces. The MX operational force, as currently planned, presents any adversary with a choice of unacceptable options. If the Soviets choose to attack our triad, excluding the 4,600 MX shelters, they can expect an unacceptable response from 200 MX missiles with 2,000 warheads. Or if they choose to attack the entire triad, including MX, they would expend almost all of their ICBM resources, leaving the U.S. with almost half of the MX warheads. In either case, any aggressor is deterred from an initial attack if the outcome is guaranteed to place him at a disadvantage. In addition to preserving our deterrent posture without adding more ICBMs to our inventory, MX will provide a new strategic capability to keep pace with possible Soviet force buildups by adding additional shelters instead of missiles. Moreover, the MX system provides the flexibility to deter a high Soviet warhead buildup. We could counter such a Soviet buildup by increasing our shelters encased with their warheads, or, in the extreme case, by adding a ballistic missile defense to MX if the Soviet actions warranted withdrawal from the existing anti-ballistic missile treaty. In this regard, we plan to construct the basic 4,600 shelters in such a way that an additional 2,000 shelters could be added within the original shelter deployment area. Furthermore, the Air Force and Army are working together to ensure that MX is designed to be compatible with the Army's low-altitude ballistic missile defense system. DoD planners believe such a Soviet force expansion against our shelters would not be attractive to the Soviet Union. In fact, the Department of Defense believes that the MX will provide the foundation to ultimately reduce the number of strategic arms in future arms control agreements. By decoupling force survivability from force size, we have the flexibility to adjust the number of shelters in the face of an expanding threat without increasing the number of missiles. Conversely, we could remove some number of missiles as part of a future arms control agreement while maintaining a constant number of shelters. This is a unique and extremely desirable feature of the MX basing mode. It provides a powerful incentive to the Soviets to seek stability rather than additional firepower. In summary, MX is vitally necessary to the future security of the United States. It sustains our strategic triad and, most importantly, sets the climate for mutual nuclear arms reductions for future arms control agreements. MX ensures our ICBM survivability into the 21st century. For 20 years, the strategic deterrent power of the United States has rested on a three-pronged arsenal of intercontinental ballistic missiles, submarine-launched ballistic missiles, and our heavy bomber force. commonly called the Triad. Throughout the lifetime of this strategic deterrent power, the Department of Defense has modernized the three elements to maintain their credibility. We have thus continually overcome the Soviets' attempts to thwart the effectiveness of this triad. For example, the range of our submarine-launched ballistic missiles, SLBMs, has been increased from the 1,500-mile Polaris to the 2,500-mile Poseidon, and now to the 4,000 nautical mile Trident I, currently being deployed in the fleet. Thus, the Trident missiles can be launched at a greater distance from the target, so that the Trident has 10 times as much ocean area in which to hide from Soviet detection. Similarly, when the Soviets perfected their high-altitude interception techniques against our B-52 bombers, our tactics were changed to low-level penetration of Soviet defenses. With new techniques and equipment, our bombers could penetrate under the Soviet radars and anti-aircraft missiles. When the Soviets developed look-down and shoot-down interception techniques, we developed and tested the cruise missile. Our B-52s will present the Soviet Union a mixed force of bombers and terrain-hugging cruise missiles. This mixed force would require the Soviet deployment of thousands of defensive systems instead of just hundreds. The third leg of our strategic nuclear triad is our land-based intercontinental ballistic missiles. Since the early 1960s, our Titan II and Minuteman ICBMs, buried in hardened vertical silos, have been the cornerstone of the triad. Their alert rate is high. They can be launched almost instantaneously and under positive command and control procedures. ICBMs are also highly reliable, reducing maintenance and operating costs. Most importantly, maintaining this ICBM force ensures that the Soviets cannot concentrate solely on defeating the other two legs of the triad. Today, this ICBM force consists of 54 Titan II missiles, a single warhead heavyweight ICBM, 450 Minuteman II single warhead ICBMs, and 550 Minuteman IIIs, a multiple independently targeted reentry vehicle system with 3 warheads. Both the Titan and Minuteman weapons have been modernized and hardened. However, despite these efforts, our ICBMs located in fixed silos are becoming vulnerable to the increasing accuracy and numbers of Soviet missiles. This is the most serious problem facing our strategic forces today. Our intelligence capabilities and verification techniques have determined that the newest Soviet ICBMs, which they are now deploying, have a guidance accuracy and warhead yield combination that seriously threatens the survivability of our current ICBM force. By the early to mid-1980s, the Soviet Union will have deployed enough warheads to destroy 90% of our ICBM force with a preemptive first strike. During this critical period, our missile-carrying submarines at sea are expected to remain undetectable and ride out a first strike and be available for a retaliatory launch. Future Soviet anti-submarine detection capabilities are unknown. Therefore, we cannot simply assume that our SLBM force will remain undetectable forever. Our alert force of B-52s, given adequate warning, can be launched and escape destruction. However, a Soviet SLBM barrage attack might overcome this force on the ground. Additionally, while we have the capability to launch our ICBMs under attack, this option, a hair-trigger situation, does not provide crisis stability. This tactic requires highly accurate and reliable assessment of the attack against us and assumes that our warning systems have not been destroyed. We would therefore prefer